In this video, we're going to go over a theorem that's going to help us find limits. So, in a way, this is another technique. And this theorem is called the squeeze theorem. Now, another name for this is, or the sandwich theorem. And so you'll hear this theorem called by both of these. Let's go ahead and look at what this squeeze/sandwich theorem states. If g of x is less than or equal to f of x, which is less than or equal to h of x, for all x in an open interval containing C except possibly at x equals C itself. And if, okay, so then we have the limit as x approaches C of g of x equals L, which equals the limit as x approaches C of h of x, comma, then the limit as x approaches C of f of x must equal L. Okay, so I mean this is a little complicated, but once we break it down, I think it's a fairly straightforward theorem, and it does make sense. And the best way to understand this theorem is by using a little diagram, a little figure, kind of showing what's going on. Alright, so the first thing is we need g of x, f of x, and h of x. And notice how this is all written, that h of x is always the greatest, and g of x is always the least, or the smallest. So for example, if we had, this is h of x, and this is g of x. So notice that no matter what, h of x is always greater than or equal to g of x. Now of course the key spot right here is this, part C. And according to this theorem, you know, of course there's a lot of functions where h of x is always bigger than, you know, another function g of x, but we do want this one point here C, where when we take the limit as x approaches C, it approaches some letter L, and as we take the limit as h of x approaches C, it also approaches L. So there's this one point right there where h of x and g of x have the exact same limit. So then we have this situation where we have f of x that's coming in. We don't know what f of x looks like, but let's say it's like that. And here is f of x. And what happens is f of x has to always be between h of x and g of x. Well, it only has to be in between h of x and g of x for some small interval. So if way down here, for whatever reason, f of x goes above or below g of x, or you know, any of them start switching their order, that's okay. We only care about this small little interval right here. So that's what it means for all x in an open interval containing C. So we have just an open interval containing C right there. And so if we know that the limit of h of x as x approaches C is L, and the limit of g of x as x approaches C is also L, well then by default the limit as x approaches c of f of x also must be L. And so what happens is, and this is where we get our name squeeze or sandwich theorem, is that h of x and g of x are squeezing around or sandwiching f of x around this point of interest. And so what happens is we're going to end up with this limit f of x, and we're not going to know what to do with it. We're not going to be able to solve f of x as far as a limit, and that's going to happen in probably the next video. So to help us find the limit, we just create two functions, h of x and g of x, where we do know the limits, and we know that at that point they squeeze together around f of x, so then we are able to use the limits of h of x and g of x to find f of x. Alright, so let's use an example. This is, I think, a fairly basic example. So if 1 minus x squared over 6 is less than x times the sine of x all over 2 minus the cosine of x is less than 1 for all values of x close to 0, we need to find the limit as x approaches 0 of x times the sine of x all over 2 minus 2 times the cosine of x. And I think these need to be less than or equal to's. Alright, so we want to find this limit right here. We want to find the limit as x approaches 0 of x times the sine of x all over 2 minus 2 cosine of x. And we put in, we substitute in the value of 0. Let's see, 0, see the sine of 0 is 0, so this is going to be 0, which is not a big deal. I mean, if this were a number, then we'd be okay. But then when we put in 0 for cosine, the cosine of 0 is 1, so then you get 2 minus 2, which is 0. So this ends up being 0 over 0, or indeterminate. I guess we knew that wasn't going to work, or we wouldn't be doing this whole problem. And then we start going through all of our techniques, and for example, we can't factor anything, we can't create a common factor and take that out. Working with numerically actually isn't too bad of an idea, and usually that's our last choice, even though that was the first thing we did. But we do have this information here, and this information is set up for the squeeze or sandwich theorem. And if we look at these two functions, so we have a function 1 minus x squared over 6. So if I were to sketch that out, so I'd go up to 1, and a negative x squared means it's a downward facing parabola, and the 1/6 means it's fairly wide. So it looks something like this. So this is the function 1 minus x squared over 6. And then we have the function just 1, so that's just a straight line across. There we go. And somehow, well, we're given this. We know that for all values, this x times the sine of x over 2 minus cosine of x is actually in between them. So, I don't know exactly what this thing looks like, which is okay. So this is 1, and then this is x times the sine of x all over 2 minus the minus guess this should be 2 minus 2 up here. Sorry about that. 2 minus 2 cosine of x. Make sure you fix that in your notes. I put the 2 here, but I forgot to put the 2 there. Alright, so because of this setup, this is of course set up to use the sandwich or squeeze theorem. So all we have to do is the following. First, let's take the limit as x approaches 0 of 1 minus x squared over 6. Well, you just substitute in 0. 0 over 6 is 0, so you get 1. The limit as x approaches 0 of 1. We go back to substitution, and, well, there's no value to put in here, so this is just 1. Well, if the limit of this one is 1, and the limit of this one is 1, and this x times the sine of x over 2 minus 2 cosine of x is always between these two, then using the squeeze theorem, we can say that the limit of this has to be 1. So we can say, what's this? Therefore, by the squeeze theorem, the limit as x approaches 0 of x times the sine of x all over 2 minus 2 cosine of x equals 1. And there's our final answer. Alright, so this squeeze theorem, it's a little complicated. The problem actually, the concept of the squeeze theorem is complicated. The problem here is actually fairly simple. But we're going to use this squeeze theorem, I believe, in the next video to prove two important limits that we're going to have to use later on in calculus. So that's kind of the whole point of this. But, you know, you have these problems where if you end up with this setup where, you know, you have this limit you can't find and it's in between two other limits, then that's pretty much an indication that you're supposed to be using the squeeze theorem or the sandwich theorem to get the final answer.